Hello, third grade friends. So today we're doing Unit 1, Lesson 3. It starts on page 11, and this is a little letter describing a strategy that you can use for practicing memorizing your math facts. Like we've talked about before, it's so important that you are working on building fact fluency. So your own teacher might have a plan for this, so I'll let them describe how they want you to do this. But here you can see like a list. And basically the way this works is you can have somebody quiz you. And so they could do it in the order increasing. They could do it in mixed up order or mixed up division, multiplication or division. And you want to be able to rapidly be able to answer all of these questions for your 5s, and then soon with your 2s, and then soon with your 10s, and then your 9s, and then in another, I think the next unit we'll do, the 3s and 4s and 6s and 7s and 8s. And then pretty soon you'll have all your math facts memorized, and that's going to be so helpful for the rest of your math life. So please start working on that. You should be spending a few minutes each day, maybe going through some of these, and then identifying which ones you don't know, and then trying to help yourself remember those facts, okay? All right, now let's move on to page 19. We're going to explore arrays. Now, you might remember arrays from the end of 2nd grade with this book. An array is an arrangement of objects in rows and columns. You can use multiplication to find the total number of objects in an array. And let's go ahead and just to help you remember, draw some waves and a little boat and a little person with a paddle. They are rowing, and you can only row side to side. You can't row up, right? You can only row across a surface that is horizontal. And a column, like in fancy buildings, you might see these fancy columns, right, that are standing up and down, and they usually will be like supporting some building or something like that. So columns are up and down, rows are side to side. Keep that in mind. Okay, so show me rows, columns, and rows. Good. Okay, so just remember that. Here we have 2 rows, row number 1, row number 2, of 5. So 1, 2, 3, 4, 5. This one also has 1, 2, 3, 4, 5. 2 rows, 5 columns. The 2 by 5 array, it is 2 times 5, and the total number of dots in that is 10. Okay. So now we're going to write multiplication equation for each of these arrays. How many flowers? So here we have 3 rows, and then 1, 2, 3, 4 columns. So this is a 3 by 4. You can go ahead and count those. I'm going to count by 4, so 4, 8, 12. You could count them individually if you like. It equals 12 flowers. All right. Next one, how many stamps? 1, 2, 3, 4, 5. 5 rows. 1, 2, 3, 4, 5, 6 columns. So this is a 5 by 6. And let's count by 5s. And we'll go to our 6th because we have 6 groups of 5. So 5, 10, 15, 20, 25, 30. We really could do 5, 10, 15, 20, 25, 30. 30 stamps. How many mugs? How many rows do we have? 3 rows. How many columns do we have? 1, 2, 3, 4, 5, 6, 7. Okay, now you know 1 group of 7 is 7. 2 groups of 7, 7 plus 7, which is 14. And then 14 plus 7, 4 plus 7 is 11. So then now you have 2 tens, so 21. 3 times, oh, I almost wrote 4. 3 times 7 equals 21 mugs. Okay. I'm not going to write in a math journal, but I can write my potential word problem on my math board. It says, write a word problem that you can solve using this array. Show how to solve your problem. So you could say, Al had 1, 2, 4 rows of pictures on a photo banner. Each row had 1, 2, 3, 4, 5, 6, 7, 8. 8. How many photos were on the banner in all? Question mark. And then you would have 4 rows, and then 8 columns, so that would be 4 times 8. And you can count them. If you'd like to just count them, that's fine. You can also do 1 group of 8 is 8. 2 groups of 8 is 16. 3 groups of 8, 24. 4 groups of 8, 32. Photos. Right. Let's go ahead and turn that page. Now we're going to use the symbols greater than, less than, or equal to describe looking at these different arrays. So by looking at the arrays, you can usually see pretty easily which one's bigger if it's obvious, you know, like this one is obviously bigger than that one. Sometimes if they're similar looking, you might want to do the problem or count them. But let's take a look. So this is a 3 by 2, only 6 dots. This is a 2 by 4, that's 8 dots. So 8 is greater than 6. This one is 3 by 3. This one is 3 by 3 but plus 1 more. So 4 by 3, 3 by 4, which means it is greater. Or sorry, this one is less than that one. So the 9 is less than that 12. These, it's 3 by 4, 3 by 4. Which one's bigger? Is there one that's bigger? No, they're equal to each other, right? They're the same amount. What about right here? We have 2 by 1, 2, 3, 4, 5. 2 by 1, 2, 3, 4. Which one has more? Well, the 5. So this is actually 10 is greater than 8. This one I think is pretty clear. This 9 is less than, that's 20. Yeah, so 4 by 5, 20. Go ahead and see if you can do the rest of them on your own, and then check with me. Okay, here we go. We got a 3 by 4, that's 12, and a 3 by 5, that's 15. So 15 is greater than 12. Over here, we could just see this one is bigger, greater than, and then this one has more columns, so that one, this is less than that. Okay, draw 2 dot arrays and compare them using symbols. Then write an equation for each array to show that your comparison is correct. You can try your own, or you can do the same one as I do. I'm going to do 1, 2, 3, 1, 2, 3. So this is 2 by 3. And I'll compare that to 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2 by 5. 2 by 3 is a total of 6. 2 by 5 is a total of 10. 6 is less than 10. Okay, let's go ahead and now flip over to this side. I'm going to make a math drawing to solve these problems. Okay, make a drawing for each problem. Label your drawing with a multiplication equation, then write an answer to solve the problem. The clarinet section of the band marched in 6 rows with 2 clarinet players in each row. How many clarinet players were there in all? So we'll make a drawing. So 1, 2, 3, 4, 5. There's 6 rows, and in each row there are 2. So this is a 6 times 2, and we can count or just think, what's 6 plus 6, right? And what is 6 plus 6? It's 12. Clarinet. Okay, Molly put some crackers on a tray. She put the crackers in 3 rows, so 1, 2, 3, 3 rows, with 5 crackers per row. Remember, per is another word for like each. So 1, 2, 3, 4, 5. 1, 2, 3, 5. 5, 2, 5. Now we have a 3, 5, 5. And then we can count by 5s. 5, 10, 15. 15. If you're feeling good, I want you to try these next 2 on your own. If you'd like to stay with me, stay with me. Okay, here we go. Miss Shahin set up some chairs in 7 rows with 5 chairs in each row. 1, 2, 3, 4, 5, 6, 7. And then we'll do 1, 2, 3, 4, 5. Now, could we draw all of these in here? Yes. You don't really have to. You can just do this part and then recognize that it is a 7 by 5. And now you know that you would sort of like, it's like dot, dot, dot. You would go out that far. You just don't have to draw all the circles. So 5, 7. So let's count by 5s until we have 7 groups of 5. 5, 10, 15, 20, 25, 30, 35. If you wanted to use the picture, you could count each of these beginnings of the rows. 5, 10, 15, 20, 25, 30, 35. Pretty neat. 35 chairs. All right, 17. Zach has a box of crayons. The crayons are arranged in 4 rows with 6 crayons in each row. So 1, 2, 3, 4, and then 1, 2, 3, 4, 5, 6. 4. So this is a 4 by 6. So one group of 6 is 6. 2 groups of 6 is 12. 3 groups of 6, 12 plus 6, 18. 4 groups of 6, 18 plus 6. You know, 18 plus 6 is 24. 24 crayons. Okie dokie. Go ahead and turn that page. Last part for us today. Explore commutativity. Say that. Commutativity. So we've talked about this before, about how it doesn't matter which of the 2 factors you put first in a multiplication equation, because the product will be the same. Remember, factors are the things that you're multiplying, and the product is the answer. So addition has the same property, but it's called the commutative property of addition in the addition. This is the commutative property of multiplication, and here's what it says. Multiplication is commutative. the commutative property of multiplication states that you can switch the order of the factors without changing the product. Okay? So I like to think flippity floppity commutative property. Maybe that'll help you, because later we're going to learn about different properties, and so if you're wondering how to remember which one is the commutative one, just think to yourself, flippity floppity commutative property, because you can flip and flop the order of the products and it's fine. You can't do that with division, you cannot do that with subtraction, but you can with multiplication and addition. Okay. Solve the problems using the commutative property. Make a math drawing for each problem, write the multiplication equation, and answer the problem. Katie bought some stickers. She put the stickers on her folder in 6 rows of 2. So you could say 6 rows of 2. We're going to say that's equal to 2 rows of 6, and that's equal to 4, 5, 6. Okay. That is equal to 12 stickers. Okay, Marco also bought some stickers. He put the stickers on his folder in 2 rows of 6. So that's 2 times 6, which is equal to 6 times 2. So this time we'll do the 6 times 2. 1, 2, 3, 4, 5, 6. And then 1, 2, 3, 4, 5, 6. And that is still what? 12 stickers. Because of the commutative property. Go ahead and try number 20 and 21 on your own, and then hit play when you're ready. On Monday, Juan helped Miss Chang clean the art cabinet. He packed jars of paint with 3 boxes, or in 3 boxes with 7 jars per box. How many jars of paint did Juan pack? So that would be 3 groups of 7. 1 group of 7 is 7. 2 groups of 7. Here. 4, 5, 6, 7. 1, 2, 3, 4. 2 groups of 7 is 14, and 3 groups of 7 is 21. So 21 jars. On Tuesday, Therese helped Miss Chang. She packed jars of paint in 7 boxes with 3 jars per box. How many jars of paint did Therese pack? So she had 1, 2, 3, 4, 5, 6, 7, and then 1, 2, 3 in each, right, like that. So she had 7 times 3 is also equal to 21 jars. And I remember when I was a kid, I didn't really pay much attention to the properties because I was like, who needs that information? But if you think about this, this cuts the number of math facts that you need to cut or need to memorize in half, because of instead of having to remember 3 times 7 and 7 times 3, you just memorize one of them, and then you're asked the other one. You'll just flip them around and you'll be like, oh yeah, it's 21. Okay, so flippity floppity commutative property, don't forget it. See you next time. Thanks for watching, and good luck if you have an assignment. All right, bye-bye.